this should all be old stuff. Okay, midpoint and distance gets covered in algebra. Perimeter, circumference, and area stuff. It's things you've done since probably elementary. Okay, so it's just a matter of kind of refreshing your brain on it, making sure you got the formulas down. Okay, but this is more like a review section in the first chapter. The other stuff we did the first part of the week is the new stuff. That's the more important thing. Midpoint and distance we'll come back to eventually. Perimeter, circumference, area, we have specific chapters on that, but we'll go beyond it. This is just to kind of wrap your head around it in case you run into problems that involve it. Okay? All right. First thing, there's a lot of stuff up there that I had, but I just took this from the book. The biggest thing is, guys, we've already talked about it, midpoint, right? Midpoint is in the middle, which means that when you take the midpoint of a segment, it cuts it in half. All right? This stuff today, this is midpoint formula, and this is only if you've got points given to you, so you're dealing with coordinates. If you see it right here, there's a formula right there for finding it. Actually, this is the one. I'm going to probably rewrite it bigger. This one, not so much. This is talking about on the number line. But this is more of like again, a common sense kind of thing where you go, look at that, that's 2 and that's at 10. If I went the middle of it, it would be 6. You add them up and cut it in half. Which is what most people do when you look at the middle. Now, the other formula down there, the other formula, let me write it bigger just in case. The other one is dealing with you having the endpoints of a segment that's wrapped in your, X, Y coordinate plane. Okay. And the way that goes is you essentially are finding the midpoint, the middle of both your X coordinate and your Y coordinate. So in essence, you're doing that part right there. We add them up and divide by 2. But if you remember, you do it with your X's and your Y's. Now, I know the formula says X1 and X2 and Y1 and Y2. You can write it if you want, but it really has no bearing on it because you're going to add them together. Like the X1 and Y1 are just placeholders. And in general, we'll have that in there if the order matters. But since you're adding, order doesn't matter. All right, you just have to remember for this first number, because again, you're finding a midpoint, so that means your answers are going to be an X coordinate and a Y coordinate. Like you're going to get an X coordinate for the midpoint, a Y coordinate for the midpoint. That's what you should end up with. Like when you're doing midpoint, you should never end up with one number. If you did that, you did the wrong formula, or you just forgot to do both parts or something like that. Okay? As long as you keep your X coordinates here, your Y coordinates there, it should be it. And again, for this to work, for you to even do this, they have to give you 2 points. It'll either be 2 endpoints, like this one would be A and B, and like A would be X1, Y1. In terms of their formula, this would be X2, Y2. All right, so they'll either give you 2 endpoints, like the actual numbers, you just take the numbers, throw them in the formula, or you'll have problems where they give you 1 endpoint, 1 midpoint, and again, you're still throwing in the formula, it's just you work that one a little backwards. I'll do examples on that, or at least I have you guys doing classes on it. So you kind of understand what I mean. If they give you the 2 endpoints, it's real straightforward. It takes like no time. So make sure you got the midpoint formula down. I just use capital N for the midpoint. So if you need to actually write the word midpoint, do it. You did. Just put M in there, you're going to think, every time you see an M, I'm going to do it. It's not. Can I go on past this guy? Say. Other thing, this. If you ever did anything with Pythagorean theorem, guys, this is the whole Pythagorean theorem. It's actually what distance formula is. It just has subtraction in there because you're finding the length of the sides of that triangle. In most cases, people have seen diagrams here before. Some people haven't, so that's why they just approach distance as here it is. In this case, the order kind of matters, so if you want to actually put in there the x2 and x1 and stuff, that's fine, okay, because of subtraction. But in reality, if you forget about it, it's not going to affect your answer, okay, because you are square. So again, with this is just kind of an order of operations thing. The only thing you guys will do distance-wise is they will flat out give you the two endpoints for the segment. It'll be like, find the length of segment AB. Point A is at 1, 2. Point B is at like -3, 5. And it'll say, find the length of it. Just take your two X's, plug them in there. Two Y's, plug them in there. Make sure you do your order of operations correct, and that's it. Your answers for this, as of like right now, you're going to be doing square roots, right? Because there's a big root sign there. If your answer does not come out to like a perfect square, like when you take a square root of it, like if you had 25, obviously square root of 25 would be 5. If it doesn't come out to a regular number, if you did square root of 30, you can leave it that way. You can leave it as a square root. If you really feel the need to take the square root of it and get the decimal value, you can. I don't really care which way you leave it, unless the directions specifically say which form to put it in. Like if they'll say round to the 10th or something like that. Otherwise, I really don't care. Like, so if you get an answer and you got 30 underneath this, after you do all this like subtracting and adding and stuff, leave it. You want to put that as like 5.4 maybe. You want to put it about there, then that'd be fine. Okay? Otherwise, these two formulas, if you remember doing them before in the past, which you should have, they weren't that hard to do. Okay? So it's just formulas right now. All right? So you work on those. It shouldn't take you that long. Here's the thing with this, guys. If there's a problem you get stuck on, regardless of where you're at, go through these. Okay? I just wanted to see how I was going to do prior to actually doing problems myself. You know, you could plug in on your own and so on. The first one, the 6 and 8, it says find the coordinates of the midpoint. So that means that you would go up there and use the x divided by 2, y plus y divided by 2 half. Okay, so you're basically finding the mean of both the points there. If you do the work there, did anyone get an answer to that one? 1/2 and what? 1. Yeah. So it would have been, if I were to plug those in, the 1/2 comes from doing -1 plus 2 divided by 2, because those are your two x coordinates. And 2 y coordinates would be the 5 minus 3 divided by 2. Okay? Plug in exactly what they were. I'm going to test it. Right now. It like I wouldn't care in this case if it was 0.5, but if you had a fraction like this, 3/7 or something like that, I'd just put it that way. All right, and then for the other one, you guys get for an answer on this one? Yeah.
-5.
5/2 and 6. Added and divided by 2. So it would have been, still got to count. Zeros are easy. I mean, if they give you one 0, you just have to take the other one and cut it in half. So if you add 0 to anything, it's the same. So it's easy. All right. I'm going to come back to 12. Okay, because the distance ones are easier. Now here's the thing. I said I don't really care the order you put it, like the form you put it in. If you want to leave it as a square root for the distance, that's fine. It says round to the nearest 10. If you did that, fine. Otherwise, I really wouldn't care on this case. This is what I learned. The directions specifically say something else, so technically you should do it that way. But for right now, if you leave it as a square root, that's fine. Okay. So again, this is distance, which was x minus x squared plus y squared. So essentially, all you need to do is take your two x coordinates and subtract them. Y coordinates, subtract them, square root of them. So if you do all that, if you plug it in all incorrectly, you plug it all incorrectly, not incorrectly. What should you get for an answer there? What? Square root of 64, which was your 8. Alright? And then for the other one, big. What do you get for 20? Square root of 100, which is just to see one plugged in, like if I took 20 and plugged it in, anyone's wondering. My two x coordinates here are 2 and 10, so I would do 2 minus 10 squared plus negative 6 minus 0. 2 minus 10, that's negative 8. That's negative 6 squared. So then underneath there you got 64 plus 36. That's where the 100's at. Alright. Then on 12, did someone get an answer for 12?
Wait, but I was going to ask a question about
Oh, okay.
But there's supposed to be just one answer for this, or is it just one? Because like, I added like 164 and then the square root of those.
Which one?
Wait, no, 18. Wait, I don't know. Like, you know how you took the square root of 64 and then 100, you add those two?
These two right here?
Yeah.
Like two separate problems.
Oh, okay, that's right.
That was 18 was 8. Anyway, answer on here.
16 negative
16 negative 15? Alright. How'd you get that?
Because the 3 comma minus 5 is the midpoint. And then to get to y, it was negative 10 from the 3. So it was like 13 was the difference, so I just added 13 to the 3. And then like with the negative 5 and the 5, 10 was the difference, so I just, since that went up, I had subtracted 10.
Yeah. Alright. You guys follow me saying that?
Wait, I did. I have a question.
Yeah.
I came up with 13 negative parameters. Did I put it into a problem? Like the x equals the midpoint, and then you just put in what it is and make the x minus 10 equals 8. And then
Okay. You would go, it wouldn't be x minus 10 or x minus 10 over 2 equal to 3. Okay. If you were to write out work, what you would do, you would take the midpoint part, like the whole x plus x, which is what this is. If you're trying to find an x coordinate, they give you one x coordinate right there. And then they tell you 3 is the midpoint, so that goes on that side, which would give you x minus 10 equals 6, so x equals, that's where the 16 technically comes from. But, like you were saying up there, if you know this is in the middle, it has to be, you knew to do the subtraction, right? Then, because if it's in the middle, it's evenly spaced on each side. So all he did was he found out the difference between the two, and just used that to come up with the other point. So like you were saying, from negative 10 to 3, the difference is 13. So I go another 13 spaces away, so 13 plus 3 gives you the 60. 5 is negative 5 is the difference of subtracting 10, so you subtract another 10 to get negative 15. And that works just fine. Okay? If you want to write the stuff out in the formula, you can. Like if I did the y coordinate, I would do y plus the y that's given to me divided by 2. Again, just that's coming straight from that formula. And I would set it equal to whatever the midpoint is that they tell me right there. And if you solve that out, that'll also be negative. In a lot of cases, it's a lot quicker just to kind of count or do the subtraction stuff anyway. Okay, you know, it's in the middle. They're both going to work. All right. So just make sure you're not confusing the formulas up. That's usually the only thing that really kills you. All right. So on to the whole perimeter and area. Should be again. It should all be like review stuff. So kind of go through it fairly quickly. All right. So for perimeter, most people should have general idea of what perimeter is prior to coming in here. So just if I would say find the perimeter or something, I'm just saying what's the length around the outside of that object. It could be anything: rectangle, square, triangle, circle, trapezoid, whatever. The definition for that will never change. The only thing that really has a formula for perimeter is a circle. The rest of the objects you work with, the polygons, are going to have segments for the side. Lengths of segments are you just count how long they are. So with the other shapes, you're not going to have formulas in reality. Like there's going to be probably stuff written out. If you look it up in the book, they're probably going to have a formula thing. If their circle is 4 times the side length. But if you remember, perimeter is simply adding up the sides. You don't really need a formula. Okay? Alright. So without even having a formula, I can give you that and I would say, look, what's the perimeter of that shape right there? If I said, what is the perimeter for that? Did you come up with the answer? 40? Is that right? You guys agree 40?
Yeah.
Okay. And where do you get the numbers from? Like how do you know what these two sides are? How do you know they're the same length? There's a little line telling you they're congruent, right? Just mark that one. So you got 13 there, you got 7 there. And then you just add them up. That's what it's for. Perimeter should never really be that big of an issue, guys. It's just a matter of remembering the basic things. Now I can give you any kind of shape I want, even one that doesn't like fit what area formulas are going to work with. You should still be able to find perimeter. Okay? Now, this would be the only one, like I said, that you'll have a formula for. The circle is the perimeter of it. It's called the circumference of it. Usually, this is the formula most people screw up because they get this one confused with the area formula all the time. When we get into the actual chapter for it, I'll probably stress this a lot more, but when you're measuring perimeter, when you're measuring area, the way you write the units changes. Like when you do perimeter of something, like a perimeter, an example of a measurement for perimeter could be perimeter equals 10 centimeters. Okay? With the units, there's nothing attached to it, it's just flat out units. But if you remember when you do area, if the area was 10, it'd be 10 square centimeters. Okay? So the difference between these two, sometimes if you can remember how the units go, it'll help you remember the difference between circumference and area. Right? Area is always the one that has the square term. Circumference is the one that doesn't have the square term. Because most people remember there's two formulas, which that's the circumference one. You remember. And it's the one that doesn't have the r squared in it. A lot of people, as soon as you do something with the circle, pi r squared is what comes out of people's mouths, because that's the one that gets used a lot. That's just the one that sticks in people's heads for some reason. Okay? And after you pull through that, most people would come up with 2 pi r circumference, which is the pi r squared first. And what I was saying, the difference between them is, since I brought it up, area is the pi r squared. I know I didn't talk about area yet, but since I brought it up, I'll do it now. The difference again between them is area. When you do units, you do like centimeters squared. So the r squared thing has to go with the area because of the way you write units. In general, area is things squared. And then when you got the circumference part, there's no squared term there because perimeters, circumferences don't get written unit-wise with that term, the squared part. So you just got to kind of keep them, organized in your brain somehow. Really don't care how you get them organized, you just need to make sure you get them there. Okay, and these formulas are the same. It's however you can remember it, you remember it that way. Okay. All right, so on to area kind of stuff. Area, if you want the basic definition, total number of square units that some kind of shape contains. Again, area deals strictly with two-dimensional shapes. We're not dealing with 3D yet. As soon as you move to 3D, this technically changes to surface area, but we're only dealing with flat shapes, so strictly with area. The shapes that you'll deal with on the work today are going to be rectangle, and these are going to have some perimeter formulas with them too. If you want to write them out, you can. Like I said, you can always get around perimeter by just adding up the sides. You don't technically need a formula for them, with the exception of the circle. Okay, so the shapes you'll have be rectangle, which is, in here, this is called base times height, because a rectangle will relate to other shapes. Whereas probably previous to this, it's probably just been given to you as length times width. I guess they still do length times width and not the base times height thing, which is okay. It's just that in here you can relate the rectangle formula to the triangle formula, and that's why they use the base and height. Square, look, the rectangle formula works for a square. If you want to write a different formula after the square, you can. That's the side length squared. You can see it. But it would be the same as if you multiplied two sides together. It's just all the sides are the same, so they do write a different formula for it. Because when you multiply something by itself, you square it. Okay? Now, you guys remember the formula for a triangle? 1/2 base times height. You never realized before, right? If you cut a rectangle in half, it makes a triangle. That's why it's 1/2 base times height kind of thing. That's kind of where the formula is coming from. That's why they use base times height for a rectangle here. And the height, one thing I want to point out, guys, with a triangle, that H part, this height right here, the height in the base will always create a right angle. Okay? So just kind of take a note of that. Make sure you write it somewhere that the height and the base of the triangle will always make that right angle. Because there's going to be times where you think they don't give you the height, but they really do. Like if I drew a right triangle, I put my 7 right there and 10 right there. I said, what's the area? Hopefully you would go, first thing is oh, it's a triangle, so I got to do 1/2 base times height. And then the next step for a lot of people would be drawing a height. Not necessary. Because of the fact that that's a right angle, the base and the height, or however you want to write them, always make the right angle. So there's going to be times where it is facing that same way. You don't have to add any lines to these guys. You should never have to do that at this point in time. So if I was doing this problem, I would go, there's my right angle, that's my base, that's my height. This would be 1/2, 7 times 10, which is what? What's 7? 1/2, 7 times 10. 35. And this would be whatever units are squared. Okay? So just be aware of that. Make a note of it. That's going to be for any kind of shape we ever deal with. When you look for height, guys, you're always going to look for that right angle. All right? Then, of course, the last one is the circle, which we already had this formulas up there. If you didn't write them yet, there they are. And those are the only shapes you're dealing with right now. Like, when we get to the actual chapter that deals with area, we're going to move into, like, pentagons, hexagons, octagons, parts of circles, so on. So there is more in-depth stuff that you guys do outside of this right here. This is the basic area stuff, basic terms. Just understand it does build from here. I think I have like 2 problems I'm going to do, and then I want you guys to do a group thing for me. Okay? So can I go past this? Can you see it? No? Okay. All right. So let me do, I think there's 2 examples I get. I want to do a circle one just so that when you see this part, I understand what I'm talking about. When it says leave answers in terms of pi, you guys know what it is technically referring to? Anyone? Like, you do agree, right? Area formula is pi r squared, circumference is 2 pi r, correct? There is pi in there. When it says leave answers in terms of pi, what do you think is going to happen to that pi that's in the formula? It just stays there, right? So if it says leave answers in terms of pi, that means just do the work for the radius that they're asking you to. Like if it's the area, you just square it and you put pi at the end of it. If it's circumference, you do 2 times the radius and put pi at the end. All right? So when it says leave answers in terms of pi, this means don't use the whole 3.14 estimate and multiply it in there. Okay, you just mess with the radius, whatever they're saying. So if I had this circle here, and guys, the way this is drawn, it's got that line going all the way across. That means that is the diameter. Okay? Anytime the book has a line going all the way across, they're referencing the diameter. There's going to be times where they do that, and this 6.3 is actually over here. But they don't want it to be the radius. They just draw it really badly in the book. So just be aware that when they give you the lines, that's what they're referencing all the way across. So circumference here is 2 pi r, or pi times the diameter. So if I was leaving this in terms of pi, all I would have to do is go 6.3 pi. Okay, that's the diameter. The circumference formula says you take the diameter, you put pi at the end of it, and you're technically done. Okay? If it said round to the nearest tenth, then you could multiply pi into it. And guys, unless I actually specify in the problem, I don't care if you use the estimate, the 3.14 estimate, or if you use the pi button, because a lot of calculators do have buttons with pi on it. Both ways, I'll have answers for both of them. You know, you might get a little bit different estimates there, but it wouldn't matter. Okay, now for the area, this would be pi times whatever the radius is squared. 6.3 is my diameter with my radius from here to here. 3.15. All right, what's 3.15 squared? 1.9225. For this one, in terms of pi, guys, if you do this in the calculator, like 3.15 squared, it's going to go here and stop. Include all the decimals. Don't round up unless it actually says round to nearest tenth or something. Try not to round up, because this would be an exact decimal. I mean, it's exactly 9.9225. The calculator didn't round to it. So include all the decimals you can. Now, obviously, if you do something like this and it goes on beyond how far the calculator goes, round up somewhere. Like, don't go past 2 decimal places. But if it terminates, like it terminates at 5, it's exactly that, include all of them. All right? At least right now, or if the directions say yes, that's another one. Okay? All right. Here, we'll do this one, and then there's one other thing I'm gonna have you guys do. Okay. We're doing the area of that shape there. All right. First thing, does the shape fit anything that we had up there? Like the way it looks right there, does it fit any of the 4 shapes we had?
No.
No. So if it doesn't fit any of the 4 shapes, what do you think you're gonna have to do to it? Make it do it. How should I do that? Going up and down?
Yeah.
You're going up and down? So like from here up?
Yeah.
Oh, that's ridiculous. All right, then what? I need numbers, I need measurements. I've only got 20 and 16. I've got to put them on some other things.
Or you could do it down.
Where? This? This one? Okay. How do you know it's happening? Because these two are congruent. Fine. All right, so since these two, like going up and down, the two that are there are congruent, I know that this point right here is in the middle of that 16. That's where the 8's coming from. It's just cutting it in half. All right, so that means anywhere I see that line, I can put an 8, correct? Right. So I put an 8 there, 8 there. Good. There's one other thing I technically have to do. I have to get one other measurement. I need like that length right there. Or if you want to look at it up there, that 12. I get 12. Yeah. Okay, you subtract 8 from 20 because that part's 8. That part right there is 12. All right. Do I have enough information now? Yeah. I'm just going to put a 1 and 2 there so I can do the work off these. All right, so the area for the first shape. What's the area for the first shape there? 64, right? Because it's what kind of shape? It's square. What about area for the second one? You got that by doing what? 5, 12, and 60. All right. Now what do you do to them? Add them up. The total is whatever those two things together is. 256? Yeah, that sounds right. Okay, so guys, if you got shapes, you don't know what the heck it looks like, just break it into shapes you know. Okay? And that goes for like from now until the end of the book. When we get to the stuff with the area section, people are going to try and do weird stuff. They're going to try and do weird formulas that they don't need to do, where they can just break it up into things like rectangles and squares. Okay? All right. The last thing I want you to get. Yeah, that's 15 minutes. Okay. These are what you guys can do. I would like you guys to get into probably groups of like 3. Okay?